Now, this little note at the top, anytime you see the word and, it's multiplying. Anytime you see the word or, it's adding. We will get to, but we'll get to it at a slightly later time when we start working on more of these problems, and especially once we get into more of the permutations and the combinations. Now, this next question conveniently does have the word or in it, but let's see how we can handle this. The telephone numbers allocated to subscribers in a rural area consist of one of the following. The digits 780 followed by 3 further digits, or, and there's that big or, the digit 2 followed by one of the digits 1 to 5 followed by any 3 further digits. So what we have to do here is we have to look at the two cases, where this is my case 1 and this is my case 2. So my case 1, the digits 780 followed by 3 further digits. So I have 6 digits in total. 1, 2, 3, 4, 5, 6. But my first 3 have to be 780 in that order. Then we have 3 further digits, so that would be 10, 10, 10, because there's no restrictions on this. So my first case would give me 1,000 options. My second case is the digit 2 followed by another digit followed by any 3 further digits. So the first has to be 2, so we put a 1 there. The second has to be from 1 to 5, so we put 1, 2, 3, 4, 5, a 5 there. And then we have 3 further digits, which would be 10, 10, and 10. So this would give us 5,000. Then we want to know what the total number is. So since we want to know what the total number is, we add these, and that would give me 6,000 different phone numbers. Okay. Now the next one we have to deal with restrictions first. How many ways can 4 girls and 5 boys be seated in a row if there's no restrictions? Well, there's 9 of them. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Or rather, I can have 9 people in the first spot, 8 in the second, 7, 6, 5, 4, 3, 2, or 1. Now, we'll later see that this equals something called 9 factorial, which you can put in your calculator and make it a bit easy, but that's something we're going to save for the next lesson. So in total, this gives me 362,880 different ways. Now, boys and girls alternate. So for boys and girls to alternate, since we have 5 boys and 4 girls, that means you have to have a boy on each end. It just won't work if you have the girls on either of the ends, because then you won't get that alternation. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to go boy, girl, boy, girl, boy, girl, boy, girl, boy. Now I have 5 boys, so 5 can sit in the first spot, 4, 3, 2, 1. And then for girls, it goes 4, 3, 2, 1. So we take this and we multiply all of these together, and that will give me 2,880 different ways. Girls are seated at each end. So for girls seated at each end, again, I go 1, 2, 3, 4, 5, 6, 7, 8, 9. Very important, I state my restrictions first. I have to have a girl. I have to have a girl. So there's 4 girls I could place there, and 3 that I can place there. From there, it doesn't matter anymore. So I have 7 people left. 6, 5, 4, 3, 2, 1. Or this gives me just give me one quick sec. I probably should have worked this out before. So 4 times 7 times 6 times 5 times 4 times 3 times 2 times 3. Or this will give me 60,480 ways. Sam has been assigned the task of determining how many odd 4-digit numbers there are. He has been told that a number such as 2, 3, 4, 5 is a 4-digit number, whereas 0, 2, 3, 4, 5 is a 3-digit number. So again, that tells us right there when we're looking at numbers, we cannot start with 0. How many odd 4-digit numbers are there if repetitions are permitted? So I have 1, 2, 3, 4. Now, if it's odd, that means that the last digit must be odd. So of my 10 digits, 5 of them are odd. If repetitions are permitted, I can have 9 in the first spot because, again, you can't have 0. And then I can have 10 and I can have 10, which gives us a total of 4,500. If repetitions are not permitted, this one gets a bit funkier. So again, my last has to be odd, so that's 5. But now I've used one of the digits and I can't use 0, so that puts me at 8. I have now used 2 digits and I have 10 total because 0 is back in, so that's 8, and then that's going to be 7. And this gives me 2,240 with no repetitions. Now, the next one is a bit crazier. How many even 4-digit numbers are there if repetitions are permitted and if repetitions are not permitted? So, if repetitions are permitted for even 4-digit numbers, I go 1, 2, 3, 4. Repetitions are permitted, so my last digit would have to be even. Then, again, my first digit can be anything but 0. And then I have the 10 and the 10. So this works out the exact same way as the odd, and that would give me 4,500 different possibilities. Now, the next one is where it gets a little bit funkier. If repetitions are not permitted. And this will actually put us where we're going to have 2 cases. Why, you may ask? Well, my last digit has to be even. So my last digit can be 0, 2, 4, 6, or 8. But we cannot start with the 0. So since we cannot start with the 0, if I place the 0 at the end versus if I don't place the 0 at the end, that's going to give us 2 different cases. So I have case 1 where I have 0 not on end, and I have case 2 with the 0 on the end. Oh my god, I cannot spell today. So I have case 1 with the 0s on the end and case 2 with the 0s not on the end. So case 1, 0 not on the end. So that takes that out, which means that I can have 4 digits in my last spot. Then in my first spot, I've used 1 digit. 0 cannot be that digit, so that's going to give me 8 possibilities. Now I've used 2 of them and 0 is back in, so that's going to give me 8, and then that's going to give me 7. If I have my case 2 where my 0 is on the end, so that means there's only 1 possibility for the last number. Then I have 9 possibilities for my first number. I've used 2 digits, so we're down to 8, and I've used 3 digits, so now we're down to 7. So from here, what I need to do is I need to add these 2 instances. So we go 8 times 8 times 7 times 4 plus 9 times 8 times 7. And this will give me a total of 2296. And just to give the separate values right here, okay? So, the next question we're not going to get to right now because I'll get to this once we get more into permutations. I hope you guys have enjoyed.